Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Welcome to the special edition of the Uptime Wind Energy Podcast. I have Joel Saxum along with me, and I'm Alan Hall, and we work for WeatherGuard Lightning Tech. And we have not talked about the lightning issues that are happening across the United States at the moment. Also, a good bit of Europe is seeing a number of really catastrophic lightning strikes, and even in South America. So everywhere you look right now, you see a lot of lightning damage, right, Joel?
Yeah, Alan, I would say this spring, early summer, as opposed to years past, we've been getting more and more and more calls. And I think it's a combination of things. I think it's a combination of, we've had some extreme weather, right? Been a pretty wicked lightning season here in Texas, Oklahoma, Kansas, in the center of the United States. But we're also hearing that same thing from India, from Mexico, from Brazil, from the Mediterranean. We're hearing it all over the place. So that's happening. But then there's also some awareness, right? There's people that are, in the wind industry as a whole, a lot of operators have sat back and relied on their FSAs to handle things. And as these costs escalate and they're looking at lightning damages, oh, this is carved out of your FSA, or some insurance companies backing away from insuring lightning. You're starting to see more and more operators and financial asset operators come into the table saying, hey, we have a lightning problem. What can we do to solve it? And that's why our phone's ringing.
Yeah, it's been nonstop for the last couple of months. And I would say that some of the damage I've even seen on LinkedIn is shocking. Even today, looking at images from Japan of blade trailing edges is split wide open, it's expensive. And the operators you talk to, when you talk to a larger operator, says it has a couple hundred turbines. They're spending millions of dollars a year just to keep those turbines running from all the lightning damage, and the engineering staffs and all the crane work and everything else, managing the ISPs. It is a huge, massive burden on the industry.
I'd like to go back to what you said about seeing it on LinkedIn. So this is a shout out to all the amazing wind turbine blade technicians out there and engineers that are supporting them and getting these things done in the field, because we have seen some crazy damages on LinkedIn. And it seems to be the ones that technicians are really proud of fixing, right? Like, look at this 10-layer repair, 3 meters this way, this kind of crack, these kind of things, because they are difficult to repair and they're very expensive to repair. Some of these things, teams of 2, 3, 4 people are on them for 2 weeks, 3 weeks, 4 weeks, right? And the cost of all those things starts to add up. And when we're talking about repairs, of course, you have the repair team, you have the repair materials and the downtime associated with weather and all those things. But you haven't, in the grand scheme of things, contemplated what is the business interruption cost here as well, because that turbine's down. And if it's down for 2 weeks, 3 weeks, 4 weeks, and you're in high wind season, that's a lot of production. So the reason that we're starting to, I believe, see a lot of phone calls, a lot of support, a lot of things we're doing is because these costs are escalating. And the number that I was looking at just this week is, so far in 2025, WeatherGuard with our Strike Tape product has either installed on or is sending kit out or scheduled to be installed on 19 wind farms.
That's a tremendous number, actually, Joel. And I had lost track. Honestly, I have lost track because there's so many phone calls coming in. I know we have more today, even looking to get some blades protected. And the reason is, I think people are starting to realize, particularly the engineering staffs and all the accounting functions and those site managers, asset managers, that are looking at the yearly cost of managing these turbines, and that lightning number is just big. And if we're getting into the situation right now because of the IRA bill changes and the one big beautiful bill eliminating a lot of the production tax credit incentives for repowering, you start to pay attention to those expenditures that you probably have paid for in the past. Now's the time to eliminate them and keep that money into the revenue chain. It is going to be a different world in about 2 years. And as we're into that transition, what we're seeing is a lot of operators now reaching out and starting to make a connection with WeatherGuard Lightning Tech to start the process. Like, how do we improve our blades. We have some old Siemens turbines. We have GE turbines. We have a lot of 1.5s, a lot of 2X machines, which are almost everywhere in the United States at the minute. How do we protect those turbines? How do we make them better? How do I stop paying ISPs hundreds of thousands of dollars for repairs? Because I need that revenue to make my business profitable at the end of the year.
Yeah, I mean, we've talked about it in the past. It's the PTC suspenders, as I've called them, I suppose. Is in the past we've been supported by it. It's allowed for a buffer of revenue to come in that you can dip into, you can use as your operational cash. And when we talk lightning damages, a lot of times that is unknown, right? It's something that you may budget for. You may not get any. You may end up spending $1 million on this one wind farm because the erratic nature of lightning. But if you can reduce that to a known level or to a very much lower level, you're sitting pretty, right? So and I want to go back to what you said, Alan. A lot of Siemens stuff, a lot of GE stuff. That's what we see a lot of. And we've done a lot of studies. We have a ton of data on the 1X and 2X GE machines, as well as the Siemens. I mean, take the Siemens and the Gamesa products. We've been working with Siemens here at WeatherGuard and putting strike tape to protect their turbine blades around the world since 2013. So we have a long track record of it. We know how to do those. We have, standard products that go on them. And all it takes is a phone call. Just get a hold of us and we can walk you through the physics of what's happening, lightning damage to your specific turbines, why it's happening, how you can fix it. And then our big thing here at WeatherGuard, of course, is supporting you through that process. We don't want to sell you a product. We want to be your partner in fixing lightning damages. And maybe we could talk about that, Alan, a little bit. Let's talk about here a little bit about what's going on with some of these LPS systems.
Boy, the LPS systems that are coming out of the factory over the last 3, 4, 5 years, even 10 years ago, are really basic. They're essentially a lightning rod. So it's a metal receptor somewhere around the tip on the pressure and the suction side. And then there's a cable that runs through the center of the blade down into the hub area. Then it gets grounded down into the tower and to earth eventually. But it's basically a spinning lightning rod. And the concept is relatively simple, right? It's like protecting a building. You put lightning rods on a building and hopefully the lightning hits those lightning rods and everything is okay. But the problem with wind turbines, particularly as they get taller, is the physics get to be a little bit different. And what has happened as blades have gone from roughly 30, 40 meters into the 50 plus meters and now much larger than that, even offshore, 100 plus meters, is that tip speeds are high. The tip heights are much higher than they used to be. And the amount of lightning that they're seeing is changing because some of the lightning strikes are actually originating at the turbines. You're seeing more what we call upward lightning. So the number of lightning strikes that a turbine will take will be dependent upon how tall that turbine is. So instead of seeing maybe one strike a year, a lot of the turbines in the United States are seeing somewhere in the 5, 6, 7 range, depending upon where you're at, per year. Now, you think about over a 10, 20-year time span, that's a number of lightning strikes. Now, they're all may not be the big, massive lightning strikes. It may be what I term baby lightning strikes, but it's still the number of lightning strikes that you take increases your chance of having blade damage. And these basic LPS systems were never designed for that. So they've taken the knowledge that they had at 30-meter blades, and they're applying it to 60-meter blades and realizing that, maybe it doesn't work like we thought it would, that the laboratory testing that we did as part of the IEC compliance is not valid as the blades get longer. That's a reality that the operators are finding out the hard way. So the OEMs know it because they're getting the phone calls, clearly. But the operators are the ones having to go out and spend all the time and the money, generally speaking, at least in the U.S., to go out and fix all this stuff, particularly if it's out of warranty. And that's where the cost structure comes in. That a lot of operators account for a certain amount of lightning damage to happen, and the IEC spec would allow that. However, that number is much higher. And so instead of being a couple of percentage points a year that you're going to go off and spend in terms of lightning repair, it's 5 times that, 10 times that. The numbers are big, Joel.
Well, and I think that's an important concept to say here. Let's spin you back to when you said LPS systems are designed on incumbent knowledge from old systems. That's true. That's what's happening. If you look at a GE blade, look at a 37 meter, 40 meter blade, the 62 2-meter blades are basically the same thing, just like, shift, stretch, print, right? And that's kind of what they are. And now we've seen data from those cooking in the field. Cooking, I don't want to use that term. Sorry, pun not intended, but pun intended, I guess, in some cases. But we've seen soak time on these blades in the field and in various environments, right? So a lot of the stuff that we get because it's really bad is the Texas, Oklahoma, Kansas, Iowa, Indiana, up through the middle of the United States because the lightning is bad here. Another one that's a hot spot for us is India. India has really bad lightning, kind of the same setup. But we have now seen years of data, the 62.2 and the 56.9, which is essentially the same blade, just a couple meters longer. They've been out in the field since 2019-ish in a large way from 2020, 2021. So we've got a lot of these that are out of warranty where the operators are really looking at them and are starting to collect a lot of data. And that's the important thing here. And that's why I want to go back, like, to design the IEC standard and all these things. And that way of testing things is you can pass an IEC test as a certification in a laboratory, but putting these things into the field in a large scale is a different story. And what we've seen over the last few years is a lot of data on these, data from, here's your damage reports from your drone inspection. Okay, now we have years of data of lightning damages in for these specific wind farms. We couple that with lightning data from, might be a remote lightning detection service. Ideally, there's lightning detection sensors on that. That's why when we put strike tape in the field, we put the Eologix Ping lightning fleet sensors on everything we put out because we want to know exactly what's happening in the field. But we have this damage data, have this lightning data. So we're starting to develop a really big history, a complete history that we can draw from statistically of what these turbines are actually doing in the field. And we're seeing a completely different story than what is told in the IEC spec.
Oh yeah, the numbers don't line up. And when you talk to operators about it, they're expecting the numbers to line up to the IEC spec because that's what historically happened with 1.5 G machines. Like, yeah, it works pretty well. But when they move to the 2X machines and larger, what they found is something dramatically different. And we've done looked over a couple of years of lightning damage in the middle of the United States, down in Texas and Oklahoma. And we looked at 8 wind farms specifically to see what the lightning damage rates were on GE, essentially some 1X longer blades, 50-meter-ish blades, up to the 62.2 meter blades. And we looked at a sample, of over 900 turbines, right, Joel?
Yeah, it was 900 turbines. We reviewed over 415 damages. And with that was over 6,000 lightning pulses. So we looked at lightning events, lightning pulses, the total amount of turbines in varied geographies around kind of what we call lightning alley. And we came up with some very interesting results. And I'm going to also throw this one in there. The reason we did this was we wanted to see what's really happening in the field to all of these turbines and then compare it to a wind farm that from commissioning date on the ground had an additional LPS protection with strike tape installed on it from day one before the blades were even flown. And the results are, they're pretty shocking. What we saw is rates of damage. When we say rates of damage, that is lightning strikes to damages on the blades. And we also caveated that with a Cat 3 and above. So we don't care as much about the 1s and 2s. The blades can run, not a big deal. But Cat 3 and above, which is going to be the ones that need to be repaired, what we saw was a 14 to 34% damage rate. So that means strikes to damages. If you average that out, it was right above 20% across those 8 wind farms. So we saw basically 1 in 5 strikes causing a damage of Cat 3 to 5 or above to those GE turbines in Texas and Oklahoma in our study, those 900 turbines.
And that is equal to dollars. So 1 in 5 lightning strikes causing damage, pretty much every year you're fixing blades. It's a question of how many blades get fixed and how expensive is the repair. Some of these repairs have been Cat 4s, Cat 5s, where they have not been able to repair them tips blown off, the split trailing edges, that kind of thing, where it just gets expensive to even do the repair. And then your costs are going from tens of thousands to hundreds of thousands to millions, depending upon the severity and whether you need to buy one blade or buy three. It just changes the dynamic greatly. And the thing that we were trying to learn with all the study work that we were doing is we did install strike tape on a farm in the middle of all these other farms, basically all the same turbine, to see if there would be a marked difference in the damage rate. And Joel, we saw huge improvements by putting strike tape on these GE Vernova turbines.
Yeah, so those turbines that we said there that had that just above 20% damage rate, that was the average. That one wind farm that we installed strike tape on was just less than 4%. So 5 times less damage on that one wind farm that had strike tape on it as compared to all the other ones around it. Now, that's basically an 80% reduction, right? So that 80% number, you can roll that over to your O&M costs, right? So if you spent $500,000 on lightning repairs this year, you could expect to only spend $100,000 next year if you had strike tape on. And I want to also say this isn't our first case study, right? This is not our first study of data. We have multiple from all over the world. We've got some that we've done in the Mediterranean. We've done some in Japan, very, very bad lightning over there. And multiple ones in the US ongoing right now. We're continuing to collect this data to show. And we have seen a lot of wind farms with 100% reduction in lightning damages. We've got 2 of them going on right now in the States that I was just looking at yesterday that have, one of them has 15 turbines that we put strike tape on and some Elogix ping lightning sensors. They have received 34 strikes over those 15 turbines and 0 damages from those. That's the kind of results we want to see.
And through this study, Joel, one of the things we were able to do, because we had the drone images and all the data, is we could see where the lightning damage was occurring, because lightning damage around the tip, like you're talking about, can be Cat 1, Cat 2. A lot of times it's cosmetic at some level. You can't get 3s, 4s and out at the tip, but generally they're not too bad. When you start taking strike damage further down the blade, when we're talking about 5 meters in, 10 meters in, those tend to be more structural, which require more time and more money to repair. And what we were finding in our study is that a lot of the GE Vernova blade damage is happening like 10 plus meters from the tip. It was remarkable, because I didn't think it was happening at that level, but the number of lightning damages that were Cat 3 plus down the blade was somewhere around 25% of the damaging strikes were down there. That's remarkable.
Yeah, and it goes completely against what the IEC standard says it should be, right? The IEC standard says basically about above 70% of lightning damages should be in the last 2 meters of the blade, so right near the tip. Not the case, right? We saw a lot of them 10 meters plus, that 25% level. And to put this into kind of engineering context, right, structurally, in these designs, say when we're talking the GE designs right here, that down conductor runs right along the shear web, right? It's attached right to it down the blade. So when you're 10 meters plus down from the tip, and that lightning has to connect somewhere, and it's always going to connect to that down conductor. If it strikes it through the trailing edge, you're going to hit the down conductor, but it's going to burn a little bit on the shear web. If it strikes it through the leading edge, it's got to go through the shear web to get to the down conductor. So no matter what, when you're 10 meters down, you're basically a Cat 4 or Cat 5. Like, you kind of skip Cat 3 right away because you're into a structural zone. It's a structural loading element, and it has a lightning damage either through it or adjacent to it. So that's got to be fixed now, because what happens to those as well is you lose the structural integrity. That thing runs for another week, another 2 weeks, another 3 weeks, and it gets weaker, weaker, weaker. You get a weird wind load, snaps that blade tip, and that blade comes around, hits the tower. It can take the tower down. We've seen that. We've heard of that multiple times. So we want to avoid those kind of things. But that was a big realization of this study, is there's actually a lot more damage happening down the blade. But this also goes gave us a really good understanding of why this is happening after we track some of the strength of the lightning strikes and what is actually going on with the physics of this LPS system. And maybe, Alan, you could share that a little bit of why we're getting strikes further down the blade.
Yeah, the basic LPS system is not really attractive to lightning. I mean, it is somewhat attractive to lightning, but looking at data from our friends over at Elogix Ping, who have all the lightning sensors, and we have lightning sensors installed all over the place at the moment, trying to track this lightning damage. And what we found is that the lightning strikes that are getting by the LPS system that are doing that damage down the blade are baby lightning strikes. They're roughly 15 kiloamps, 13, 15 kiloamps. So the vast majority of damaging strikes are not these 200 kiloamp off the IEC chart kind of strikes. What they are the littler strikes that still contain a significant amount of energy that are getting by the LPS system, seeing that down conductor, putting your hole in the blade, pumping some current in there, and creating this big repair, particularly if it goes through the shear web. So the strikes that we're trying to protect against from the IEC standpoint, when you're out in the laboratory and you see the pictures coming from the OEM and they got this lightning strike thing going on, they're looking at big lightning strikes. That's what they're out there testing. What they should be testing for is the ability to capture these little lightning strikes that are doing the vast majority of the damage, particularly on like these GE Vernova blades. It's amazing when you start to correlate the data. Like, why did the lightning strike happen 5 meters down, 10 meters down? Well, because little lightning strikes, these little low amplitude lightning strikes, don't have the strength that triggers the LPS system, right? So they don't really trip the LPS system to work. And that's where strike tape comes in, our product from WeatherGuard Lightning Tech. You need to turn the LPS system on sooner. That's basically what you need to do. You need to have the LPS system start to reach out to these lower level lightning strikes and capture them and redirect them down to the receptor system and the LPS system as it was designed. The only way to do that is to make those LPS systems more attractive, which is exactly what strike tape does. So when you see strike tape out in the field, what you'll see is that we're putting strike tape near the existing receptors. And it's not a lot of product that's on the blades. It's for actually very little in comparison to the length of the blades. But it changes dramatically the LPS performance. So instead of having these 20% damage rates, we're down to the single digits, low single digits in terms of damage rates. That's what you want to see, and that's how you're going to save yourself hundreds or thousands of dollars a year if you're in some of these rougher lightning locations like Texas, Oklahoma, Kansas, Indiana, Illinois, Iowa, even up in Wisconsin, Minnesota. You can save yourself a ton of money just by putting some simple devices onto your turbine that don't modify the turbine. The thing about strike tape is it's on the outside of the blade. It doesn't change the blade structure. It goes on in a couple of minutes. It's easy to install. It's been installed all over the world.
This is where I like to go to the next steps. What are the action items, right? So if you are interested in looking at how can we protect ourselves further, how can we lower O&M costs and unexpected costs at our site, get a hold of us. Of course, my name, Joel.Saxum, Saxum at wglightning.com, or Allen.Hall at wglightning.com. And what we like to do is every site's a little different, right? So we like to walk through things to understand what damages you're taking, because it could be different depending on topography, the layout of your wind farm, your specific environment. Sometimes it's a little bit different on lightning damages if you're in tilled fields, or if you're in cattle pasture, or if you're up on a mountain, or those kind of things change how lightning reacts with your wind farm. We've seen a ton of wind farms, so we know these things. Get a hold of us. So we like to identify the potential sites, and we'll look at your turbines. We do a little RFI, give us some data, give us some background. If you've got lightning data, if you've got inspection data with your damages, great. Where the turbine locations are. So we can locate which turbines are your higher risk ones in your wind farms. We'll look at what the installation method is. We go as far as training the technicians on site or virtually to make sure that they do the thing properly, get the installation done. Because when the installation is done properly, as everybody knows that's probably listening to this podcast, a product on blade is only as good as its installation. So we've simplified that to the next level to make sure that this thing goes well in the field and can last the 20 years left of the lifetime of your blades. So, and I want to reiterate this from a couple minutes ago in the podcast. WeatherGuard Lightning Tech, we want to be your partner in solving your lightning problems. We're not here to sell you a product and walk away. So we are going to train the technicians. We are going to support you. We're going to have regular check-ins. We're going to look through your inspections with you, give you some advice on lightning damages, what's actually happening in the field. We're going to put some sensors out there on the turbines that help you in your O&M processes and operations to know when you've been struck, which turbines have been struck, optimize your time in the field, and put our money where our mouth is, right? We know strike tape works. We sell in the aerospace industry too. Boeing, Airbus, Embraer, Gulfstream, you name it. They use our same products. We are protecting we're right around 20,000 blades around the world right now. So we know that we can help operators, and we're here to support.
And you should accept no substitutions. So more recently, GE has clearly been watching our success in the field, and new GE blades, particularly 62.2s that are coming out of the field, and some of the two-piece blades that are happening for the Sierra and also Cypress, they are including a lightning diverter, very similar to weather guards. And you'll see that now. You're seeing GE Vernova engineers add their lightning diverter to improve the LPS system on their blades, as I assume because of the customer feedback that they've been getting. The problem, and if you're receiving those blades and you're doing a lot of repowers in the next year, I think it'll happen in the United States, it'll be a lot of it, is that those devices that LM has created, it's an LM-derived product, don't last very long in some rough conditions. So the leading edge erosion is a problem, and rain erosion is a problem for those LM, GE Vernova lightning diverters. And we're starting to get the complaints coming in. Operators say, I have strike tape on my turbines. No, you don't. You have an LM, GE Vernova product that doesn't have a great service history, and you probably want to put something on that's going to last the lifetime of the blades, which is going to be a strike tape product. That's the difference. So we run into operators once in a while, and they'll say, oh, how do I know this is going to work? Well, how do you know strike tape's going to work? Well, we can prove it because we have a ton of case studies we can just provide to you. You can also talk to our existing customer base. They love to talk about the success of strike tape because they're saving hundreds of thousands of dollars. But let's go look at what GE Vernova is doing at the minute. And GE Vernova is essentially trying to copy us in what we're doing and how we do it. I would say, and you got to be careful here, is that you'll see that a lot of the GE Vernova installations, their lightning diverter goes with the airflow, which is great, I guess, because they need to protect it from rain erosion. So they need to put it with the airflow to minimize rain erosion. And we've done rain erosion testing on those products. Joel, we'll just put it up on the website, our rain erosion test of the LM wind power lightning diverters. But lightning is usually coming from the sky, which means that a lightning diverter or a strike tape product needs to be kind of pointed upwards to work effectively. And LM won't do that. GE Vernova won't do that. So what you're going to see is a lot of, with the airflow, lightning diverters around the receptors. It's going to be somewhat effective, but not great. So it looks like it's added lightning protection, but in effect, it's just minimal improvement. If you really want to attack this lightning problem, you need to direct a lightning diverter like strike tape towards the sky and try to intercept these lightning strikes that are damaging your blade. So it's as simple as that. And if you haven't worked with WeatherGuard in the past, we're really easy to deal with, right? So we're experts in lightning protection. We've been doing it a long time. We understand the problems you're having, and we can make it easy. That's the whole point. So if you have lightning damage, choosing strike tape is the right solution. Quick to install, easy to implement, proven track record. We're going to give you an Elogix Ping lightning detection system to put on each tower that you put strike tape on so you can monitor it. You can see the money you're saving. It's that simple.
So if you made it to this point in the podcast, you're clearly needing some lightning protection support. Reach out to us, right? So www.weatherguardwind.com is our website. On the website, we have contact forms. You can go through that. Or, like I said earlier in the episode, joel.saxum, SAXUM, at wglightning.com. I've always got that email in my hand. So that's a great way to get a hold of us. The other one, if you want to get a hold of us right now, on that website is a chat function, lower bottom right corner. We're monitoring it all the time. So we're always ready for a conversation. Like Alan said, we're easy to get a hold of. We're easy to deal with. So now you have no excuses to get some upgraded lightning protection support for your fleet.
Yeah, just reach out to weatherguardwind.com or just get a hold of Joel and I. We're on LinkedIn also. We're easy to find out in the world. And thanks for listening. Right? We appreciate everybody that's participated with the Uptime Wind Energy podcast. We put this podcast together to disseminate great information about what's happening in wind. And we just thought we ought to take a few moments to talk about what we actually do for a day job, which is lightning protection for wind turbines all around the world. So thank you for listening. We'll see you here next week on the Uptime Wind Energy Podcast Spotlight.